There's a period of time we identify as the Dark Ages, where, yes, there's matter and energy but nothing shining yet. Today, we have the internet, where we can easily log every little detail about our lives and upload it onto the web, where it'll stay forever. Future generations can just look things up and see everything that happened in our lives firsthand. However, for us in the present, things aren't as easy. We have to invest thousands of hours of research to figure out what happened in the past, and through that effort, we can learn how things might progress in the future. Recently, we started getting chemical data back from the surface, and with it, came some surprises. In that research, scientists discovered areas in space where several galaxies have vanished, and something else has emerged, changing everything. Join us as we explore what happened that caused these galaxies to disappear into the abyss and what the new changes might mean for our future. One such mystery is the greater unconformity. The mysteries of both the universe and Earth are intriguing and complex, from the cosmic microwave background cold spot to the greater unconformity, which has baffled scientists for years. It represents a literal gap in the geological record, a time span between 100 million and 1 billion years where there is almost no evidence of geological activity on Earth. It's as if, for this window in time, the Earth's geological clock simply stopped ticking. The thought of this is downright terrifying because we're not talking about a year or two but millions of years, just lost, with no records or insights into what happened and how Earth eventually recovered. If you've made it this far into the video, you clearly share our passion for exploring the mysteries of the universe and uncovering the truths behind these groundbreaking discoveries. We dive deep into these topics regularly, bringing you the latest updates from space science, astronomy, and beyond. If that's something you're excited about too, make sure to hit that subscribe button and turn on notifications, so you never miss out on our upcoming videos. We've got so much more to explore together, and your support helps us keep bringing you content that makes the wonders of the universe more accessible. Most of the time, gaps like these are mere theories, but in the case of the greater unconformity, there's substantial proof that it did happen. The unconformity has been observed in various rock sections around the world, appearing as a small blip on the geological timeline in some areas, while in others, it spans hundreds of millions of years. This vast gap in the geological record is one of the most significant unconformities ever discovered. One of the most interesting aspects of the greater unconformity is that it's not just a matter of missing rocks. The rocks formed during this period were almost entirely eroded, leaving barely any evidence of their existence. The remaining rocks show signs of weathering and erosion, indicating that they were exposed to the elements for a long time. So, what happened during this mysterious period of Earth's history? One theory suggests that Earth underwent a period of extreme weathering and erosion, which removed almost all existing rock formations. Another theory posits that a massive tectonic event occurred, destroying old rocks and forming new ones. This theory makes sense, considering that Earth has undergone other tectonic events in the past. As it turns out, space operates in a similar way. While on Earth, we have the greater unconformity, in space, there's the Great Void, a massive, empty region in the universe that scientists are still struggling to understand. It's an area almost entirely devoid of galaxies, stars, and even dark matter. What caused several galaxies to vanish here, and could this be happening elsewhere? The Great Void is a perplexing phenomenon that has puzzled scientists for years. Its sheer size and emptiness make it a fascinating topic of study. Eridanus supervoid, where the Great Void is located, spans nearly 1 billion light-years, with the void itself measuring about 300 million light-years across, making it one of the largest voids in the universe. Though not entirely empty, it is far sparser compared to other regions in space. Scientists have come up with several possible explanations for its formation. One theory is that a primordial black hole, formed in the universe's early moments, might have engulfed matter around it, creating the void. Primordial black holes could have started as tiny quantum fluctuations in the early universe and grown larger as the universe expanded. If such black holes existed, they could have swallowed massive sections of space, leaving behind a vast emptiness. Another explanation involves cosmic strings, hypothetical objects thought to have formed during the universe's early stages. These incredibly dense and long strings could have pushed matter away, creating empty regions like the Great Void. In this scenario, the void is simply space where matter was displaced, with no need for dark matter or anything else to occupy it. A third possibility is that the Great Void is a result of cosmic variance, meaning that the universe isn't entirely uniform on large scales, and some regions may naturally be emptier than others. This theory suggests the Great Void might just be an example of this natural variation. However, there's also the issue of perspective. Have we been viewing everything incorrectly this whole time? The concept of the universe expanding was first proposed by astronomer Edwin Hubble, who observed that galaxies were moving away from us, and the farther away they were, the faster they appeared to be moving. This led to the theory of an expanding universe. But in the late 1990s, scientists discovered something startling: the universe wasn't just expanding, it was accelerating. This discovery, made by observing supernovae, shocked the scientific community, as it was expected that gravity would eventually slow down the expansion. Instead, an unknown force, dubbed dark energy, seemed to be driving the acceleration. The nature of dark energy remains a mystery and is one of the most significant puzzles in modern cosmology. As the universe continues to expand, galaxies will eventually move so far away that they will appear to be moving faster than the speed of light, making them impossible to observe or reach. This means that entire galaxies will disappear from our view, as their light will never reach us again. Amidst this, there's the cosmic microwave background, CMB, the oldest light in the universe, which still fills the entire cosmos today. First discovered in the 1960s, the CMB is the afterglow of the Big Bang, dating back approximately 14 billion years. It provides a snapshot of the universe when it was just 380,000 years old, helping us understand the early universe. By studying the temperature variations in the CMB, cosmologists have gained invaluable insights into the origins and evolution of the cosmos. However, the CMB also presents anomalies. One notable example is the CMB cold spot, an unusually cold patch of space that has puzzled scientists. The cold spot could be a statistical fluke or perhaps caused by a supervoid, a large empty space in the universe that interacts with the CMB radiation passing through it. Some theories even suggest that the cold spot might be evidence of exotic physics, such as parallel universes or cosmic strings. Then, there's the mystery of dark matter, the invisible substance that makes up most of the universe. Without dark matter, galaxies wouldn't exist, yet some galaxies seem to be missing large amounts of it. Scientists have identified 19 dwarf galaxies, much smaller than the Milky Way, that defy our understanding of galaxy formation. These galaxies have far less dark matter than expected, raising questions about how they came to be. Dwarf galaxies usually have more dark matter than larger galaxies due to their weaker gravity, which makes it harder for them to hold onto gas. But these outliers tell a different story. Researchers are still trying to understand how these galaxies formed and why they lack dark matter. Some scientists speculate that nearby galaxies may have siphoned off their dark matter, while others propose that these dwarf galaxies might have clung to their normal matter instead. Whatever the case, these discoveries challenge our current understanding of the universe and could lead to revisions in the models of galaxy formation. The study of dark matter is crucial to understanding the universe. As we learn more about its role in galaxy formation, we also gain insights into the larger structure of the cosmos, including our own Milky Way. And with the possibility of galaxies disappearing into voids, like the Great Void, it's important to stay ahead of these mysteries before it's too late. For now, we may be safe, but the universe holds many secrets, and we're just beginning to uncover them. If you enjoyed this deep dive into the universe's mysteries, please give this video a thumbs up and subscribe for more. We'll see you in the next one.